Hi, welcome back to Missing Chemistry. This is Stoichiometry Lesson number 6. Sodium peroxide reacts with water and produces sodium hydroxide and oxygen. Write the balanced equation. All right, well, sodium peroxide is going to be Na2O2. You think it would be Na2O, but no, it's Na2O2. Reacts with water, H2O. We really should call it dihydrogen monoxide, but produces sodium hydroxide and oxygen. All right, now let's go ahead and look at this equation. If I were to put a 2 in front of the sodium, like you'd be tempted to do, you're going to get 4 oxygens, and then you're going to have 4 hydrogens on the other side. So let's go ahead and put a 4 in front of this. Let's go ahead and double that amount. And when we do, we're just going to put a 2 here. That'll give us 4 sodiums, and we're going to need 4 hydrogens, so we need to put a 2 there. So let's see, we get 4 oxygens and 2 oxygens, this means 6 oxygens. On this side over here, it's 4 oxygens plus 2 oxygens makes 6 oxygens. So this equation is balanced. All right. Now, the next question says, what mass in grams of O2 is produced when 50 grams of Na2O2 react? Okay, so we want to know how many grams of O2 is made. So we're given 50 grams of Na2O2. So we're going to go from my grams to my moles to their grams. All right, so let's go ahead and start this. Before we do, we need to know what is the molar mass of Na2 because we need to know this. So this is going to be 22.99, and the O2, of course, is going to be 16.00. And so what we need to do is go ahead and figure out that mass. So we get 22.99 times 2 plus 32 tells me that's going to be 77.98 grams. So we're at 77.98 grams per mole. Now we can do this question. So we go 50 grams of Na2O2 times 1 mole of Na2O2. Remember, we have to go from my grams to my moles first. So we're going to put that 77.98 grams right there of Na2O2. Then we want to convert my moles to their moles. So what's the molar ratio between Na2O2 and O2? Oh, it's a 1-to-2 relationship. So we put 2 moles of Na2O2 on the bottom and 1 mole of O2 on the top. And we want to know this in grams of oxygen, not moles of oxygen, so we got to do one more step. So we go from my grams to my moles to their moles to their grams. So we're going to put 32 grams. You say oxygen 16 grams, but this is diatomic oxygen, right? It's because it's O2. So now we can cancel our common units. And that's what we're going to do right now. And then we're going to take our old calculator and we're going to figure it out. So we take 50 divided by 77.98 equals divided by 2 equals times 32. And I get 10.25 grams. All right, that's how many grams of oxygen I make. So I get 10. That's actually going to be 10.26 grams to be more correct of O2. Snarls. Okay, now the last question. What mass of grams of water is needed to react completely with the Na2O2? So what we need to figure out is a couple things. What mass in grams of water is needed to completely react with Na2O2? So what we're going to do is we're going to take let's see here. Yes, I know what we're going to do. Got it. So what we're going to do is we're going to look at the Na2O2 first, and we're going to make sure that we have everything the way we want it to be, and it looks like it's going to be good in that respect, because you were given 50 grams of Na2O2, right? So we are going to assume that we're using 50 grams. Again, that's what I need to double check. So we go 50 grams of Na2O2 times 1 mole of Na2O2 divided by its molar mass, which is 77.98 grams, right, of Na2O2. Now we want to convert that into moles because we're going from my grams to my moles to their moles to their grams. That's our flow path. So we're going to go ahead and do this. And so we will put, what is the molar relationship? Well, we've got 2 moles in the bottom here because that's how many moles in the balanced equation we have. Okay, and then we're going to have how many moles of water? We have 2 moles of water. So when we have 2 over 2, that's like saying 1 over 1. But to keep it clean, just do it this way. And now we're going to need the molar mass of H2O, of course. So we can put that right over here, I guess. So we have H is 2 times 1.01. And of course, 1 for the oxygen is 16.00. When you add these up, you get 18.02 grams per mole for water. So that's what we're going to put here. 18.02 grams of H2O. And now we're going to do our math. So remember, this unit cancels that unit. We'll cancel out our common units. Okay, and then we're going to multiply and divide. So let's get the calculator again, and let's do this. 50 divided by 77.98, okay, times that, times 18.02, and I get 11.55 grams of H2O. Okay, 11.55 grams of H2O. Snarls. Speaking of snarls, you guys be snarly. And we'll see you back here at Moosine Chemistry.